Assalamualaikum and good day all class. Today I would like to go into chapter 3. In the chapter 3 we have five subtopics here. The first one is introduction. Second one heat loss. Heat load. And then the third refrigerant agent. And fourth subtopic is the development of refrigeration. And then the last one is unit of refrigeration. As I mentioned before, in the previous class on chapter 2 and then chapter 1, we try to learn in deep on the component of refrigeration. But before that, you should be understand about what the refrigeration condition and support how refrigeration works. So like the refrigerant itself and the cycle itself. And also you can refer the video on the lab breathing on the first week. I also mentioned about the refrigeration cycle and component. You can see also there as like a sample of refrigerator system, the fridge and the split system, or you can see also in the like the high building refrigeration system. Okay, back into chapter 3. We go first on the introduction. In the introduction, refrigeration is a process for drawing heat from substances to lower their temperature, often for purposes of preservation. So actually, we try to keep the heat in certain temperature and also the humidity we can control. And then we go to second bullet. Refrigeration is modern, portable, also depends on the insulating material. They are thin yet effective. So now refrigeration not only in a small size, also in the thin of thicknesses. And then this is one can be easy to mobile condition. Okay. And then we go to next bullet, talking about wherever fresh or frozen food must be stored, processed, transported, or sold, refrigeration is indispensable. Thus, appropriate refrigeration machinery has been developed for trains, ships, factories, and cold storage plants are used not only for food but also for storage. You know, for storage? Yes, this is like you keep the what high value uh, thing to keep in a certain condition. Maybe expensive bag, expensive of where you can keep there by certain condition, temperature and humidity. And then we go to the last of bullet, talking about the process of removing heat from a space or substance to reduce its temperature and transferring that heat to some another space or substance, for example, air or water. This is the technique by which we keep the temperature of the given space lower than its surrounding or environment. The heat is removed from the substance to be cooled and transferred to air, water, or other cooling medium. To remove the heat from the given space, we evaporate a volatile liquid by lowering its pressure. During this process, the liquid become vapor by taking heat from the system, making it cold. Okay, so this one introduction is talking about the refrigeration condition and function. Okay, now we go to next subtopic about heat load. So what is the heat load itself? The amount of heat that must be supplied, moved to keep the building or room air at the desired temperature is called the heating load. The heating load must be determined because it is used in the selection of heating equipment, piping, and duct sizing in energy utilization studies. Currently, determining the heating load is fundamental step in the planning heating system. So actually, before we start to uh, design refrigeration designing in a certain building, we should be not to the output first, what we want to keep it, temperature, pressure, and also the humidity. So, and then how the room condition work. Is it for human? Is it for the equipment or something else? So we should be designed first before we supply the heat load. So heat load itself can be what we call from the human temperature itself can be for the equipment temperature like computer also produce the heat in the environment. So we should be consider to keep the temperature in the our convenience. So the last bullet in this subtopic talking the total heat load to be handled in any application is the sum of the heat from the four sources. So can be heat leakage load is the heat that infiltrates the refrigerator through wall, ceiling, roof, and floor. So can be from this source produce the heat leakage. So the walls can be produce also the heat leakage. Maybe the wall is dividing from the outside. So the outside part is maybe directly uh, introduced to the sun. So that's why the wall will be transfer and penetrate into the room, inside room. So that's why the wall should be considered. Is it the contribute and produce the thermal? And then ceiling also, maybe from the roof directly, and then absorb the heat from the roof, and then when we contribute heating in the room. And then floor, maybe floor we design is around the maybe from the basement. That basement is maybe we keep the some uh, equipment that produce the heat. Also, will we also contribute in the room to influence the thermal inside. So which we in the our focus in the designing. And then we go to the second one. The product load is heat from the warm food or other solids or liquid that are being refrigerated. Yes, when we try to concern in the product food should be considered also from the food itself or the liquid. And then we go to the uh, third sources is a miscellaneous heat load. Is heat introduced by light, motor, and other heat producing device located in the refrigerated area Manufacturing process and human occupancy also may contribute to the miscellaneous heat load. So miscellaneous heat load is mean from the varied source. Can be something, can be something. Can be pet. Pet also produce the heat. Can be human. Can be machinery process. Yeah. Okay. And then the last one, the service load is the heat that enter the refrigerator when door or other access means are open. So the door may be open to be in or take out the product. For example, for a variety of other reasons, this sources is often called the usage load 7. So we try to open and close the access. So the environment effluent will be giving the load into the refrigeration system. So actually, I would like to show you something example what we uh, design in the. This one is an example of designing using the programming. This one we design using the Revit program. Is very good. You can see after we the architecture finish, so hands over to the mechanical work. Then we try to design uh, for the HVAC system, and we should design the size, the airflow, and the temperature, humidity based on the room of work. So if this room is for machine, it should be designed in the certain condition. And if the condition designed for human, you can see maybe for office, so how many person inside. So this person will contribute to the heat thermal, and then we should be designed for certain person for maximum. Okay, and then you can see this one is designing using the ANSYS fleet system. So the supply from the terminal, you can see because of how many equipment designed here and will influence in the flow system inside of the room. And this one is the supply to outsider, another one. And then this one is supply for inlet. Okay, this one is your example. If you want to design something, condition should be know first what the function of room first. And then you can design all output for the HVAC system. Okay, now we go to other next subtopic on refrigerant agent. So prior to 1996, the refrigerant used in electric refrigerator were using chlorofluorocarbon, or we call CFC. However, because of increasing scientific evidence that the CFCs are harmful to the ozone layer of the stratosphere, they were banned by international treaty. So the Montreal Protocol after January 1996. Yeah? So after that, we don't use anymore this refrigerant agent. And then after that, we try to use hydrochlorofluorocarbon or HCFCS, yes, which are less harmful to the ozone layer to be used in their place until the year 2020. By the time compounds such as hydrofluorocarbon, which are behind to the ozone layer, beneath the ozone layer, are expected to have replaced by HSFS. Yeah? And then next, In the absorption system widely employed in the commercial installation, ammonia is usually used as a refrigerant to cool brine water containing calcium chloride or sodium chloride. It's then sent through pipe to cool the refrigerator space. The steam jet system is used where temperature below 32 degree Fahrenheit are not required. Water is used. The refrigerant plants are cooled or heated through an acid cycle system. Research and development is being carried out to apply the Peltier effect in various practical refrigeration systems. This is the history of the refrigerant agent from the CFC, HCFC, and then ammonia. Now we are using the R134. Yes, this is the new one, the latest. Okay, this one is a history for fourth generation of refrigeration development. The first generation is starting from the 1830 until to 1930, 100 years during period. However, occurred using ether, CO2, and so on. You can see the slide. The second generation, starting in the 1931 until to 1990, and then the third generation, starting 1990 until 2010. We should be consider ozone protection. And then starting 2010, starting for fourth generation, we should be considered on the global warming, zero, low ODP, low GWP, and so on. Okay, now we are already in the subtopic 3.4, development of refrigeration. Early methods of refrigeration, perishable food were kept in the cool cellar or in bucket lower into wells. A device still used in some areas is a room built with porous wall over which water is made to trickle as the water evaporates. The room is cool. So using this one first, the technical, by using the evaporator system, by using porous wall to penetrate the water and make evaporate inside. So this one is the first method to food perishable foods. And then second method to keep the food still in fresh by using the spring house system. Was built over the flowing water and the cooling fluid was let through in the which crop of butter and cream were placed. In the winter, farmers stored ice in the ice houses for use in the summer. Okay, like this. Similarly, natural ice from commercial ice house was used in cities until artificial method of producing ice were initiated in the middle of 19th century. Okay, actually, this spring house is to keep the food, just build like the warehouse, but together with the storage to keep by water inside, and then using the what we call coal rock keep inside the spring house. This one is a limited for to keep food storage. You can see the example how the spring house made it. This one, so the rock will keep the temperature and then the humidity from the outside. And then by using the ice block inside the spring house. By using water also. This one example of product in the food storage. Yes, this one. So now we are already in the system of mechanical refrigeration. The first patent for mechanical refrigeration was issued in 1834 in Great Britain to the American inventor Jacob Perkins. Mechanical refrigeration systems are based on the principle that absorption of heat by fluid as it change from a liquid to a gas lower the temperature of the object around. This one, the first patent that built by Jacob Perkins. I think this uh, founder is from the Great Britain. Okay, you can see the history of the refrigeration from the 1850 already starting, and then until to one 100 year of the development. Okay. In the last slide, refrigerator development history is already start in the 100 years. Actually, refrigerator work on the principle of taking a special type of gas that when it's compressed, it turns into the liquid which absorbs heat. It took 100 years. Okay, and a result from a four-man inventor before the working refrigerator machine was invented and patented from the 1834 by Jacob Perkins from the Great Britain, then go to the America. The people who pioneered the way to this invention were in the 1720, a Scotsman called Dr. William Cullen, who carried out experiment in evaporation. Next, Oliver Evan from Pennsylvania, by using compression machine. So this one already in the using mechanical work configuration history. Okay, that's all for introducing the refrigeration system and history. So I will put task to complete the week, third week attendance. So please check the ULEN. Will put the task there. So if you submit within 1 week, I will consider you attend to third week. Okay, that's all. Thank you. Assalamualaikum.